This lesson is based on the textbook Modern Welding, 11th edition. If an alternate edition is used of Modern Welding, you will have to look up the chapter that pertains to the material covered. Chapter 11. Oxyfuel Gas Welding, Equipment and Supplies. Objectives. Identify the various components and functions of an oxyfuel gas welding outfit. Identify the maximum safe working pressure for acetylene gas. Know all the safety equipment that should be worn and used for oxyfuel gas welding in various positions. Interpret the letters and number used for describing an oxyfuel gas welding rod in the AWS code. Oxyfuel gas welding outfit. An oxyfuel gas welding outfit is the basic equipment needed to weld with oxygen and fuel gas. An oxyfuel gas welding station includes an oxyfuel gas welding outfit, a welding table, ventilation, lighting, and other equipment for the welder's comfort. Oxyfuel gas welding outfit. A welding outfit consists of oxygen source and a fuel gas source, regulators with high and low pressure gauges, hoses with appropriate fittings, a complete welding torch, welding goggles or a welding helmet, and a spark lighter to ignite the welding flame. Oxyfuel gas welding outfit. This diagram shows the basics of the system. Realize that the oxygen cylinder and the acetylene cylinder are not always green and red. They can be different colors, they can be different sizes, and they can be different shapes. Be sure to read the labels on the cylinders. Oxygen supply. Oxygen can be obtained through various processes. Liquefying of atmospheric air by compression and cooling is called liquefaction. It is easy to separate oxygen from nitrogen by means of fractional distillation. And electrolysis of water is also used to produce oxygen. Oxygen supply. Oxygen used for welding is stored in cylinders of various sizes. This illustration shows a Dewar flask, a vessel used to store liquid oxygen. Oxygen cylinders. Most oxyfuel welders use oxygen from pressurized cylinders. For safety, cylinders must be of sturdy construction. An oxygen cylinder valve is specially designed to withstand high pressure. Oxygen cylinders. Threads on the upper body of the cylinder are provided for the cylinder safety cap. Oxygen is purchased by the cubic foot, measured as atmospheric pressure. Oxygen cylinders come in many sizes and are made from steel or aluminum. Safety. While in use, the cylinder valve should be turned all the way open. Cylinders should be secured in a vertical position. The valve should be closed when the cylinder is not in use. A cylinder truck should be used to move cylinders. And prior to connecting any gas cylinder, the valve should be cracked open to clear out any debris. Oxygen manifolds. With a manifold system, an oxygen line regulator is used at each welding station. A master regulator controls the pressure of the oxygen in the piping system. In manifold installations, the copper tubing connecting the cylinders to the manifold should be frequently annealed. Safety. Local and national safety and fire codes must be checked to ensure proper installation of an oxygen manifold. Safety. If a label on a cylinder is missing or is not legible, do not assume the cylinder contains a particular gas. Return the cylinder to the supplier. The color of the cylinder is not an indicator of the gas inside. Check the label. Oxygen safety precautions. Do not permit smoking or open flames where oxygen is stored or used other than intended use. Liquid oxygen may cause freeze burns. Keep all combustible materials away from the oxygen supply. Do not place liquid oxygen equipment on asphalt or any surface with oil or grease deposits. Remove clothing that has been saturated with pure oxygen. Keep valve threads clean from oil and grease. Safety. Storing acetylene in its gaseous form under pressure is not safe at pressures above 15 psi. Do not set pressure in use above 15 psi. Acetylene cylinders. Acetylene gas is usually stored in specially designed cylinders. New empty cylinders are filled with an inert monolithic filler material. The base of an acetylene cylinder is concave and usually has 2 fuse plugs. Acetylene cylinder valves come in 2 types, with a handwheel or with a square shank. Acetylene cylinders. The amount of acetylene in a cylinder cannot be estimated by the pressure in the cylinder. Acetylene cylinders should be stored and used in an upright position. Acetylene cylinders come in a variety of sizes. Acetylene cylinders. The maximum safe rate for drawing acetylene from a cylinder is 1/7 of the cylinder's capacity per hour. The rate at which acetylene can be drawn off depends on the temperature of the cylinder, the amount of charge remaining in the cylinder, and the number of cylinders providing the flow. Safety. Allowing too much acetylene flow can be dangerous. A pressure drop could occur that might cause a flashback, which means the flame burns inside the torch or hoses. If this occurs, shut off the gas immediately. Acetylene manifolds. In the case of fuel gases, fire safety is a reason for having a manifold installation. An acetylene manifold system incorporates some features not included in an oxygen manifold system: a regulator and control valves, a water seal flashback arrestor. Acetylene manifolds. Fire safety codes must be checked to properly install an acetylene manifold. Safety. Copper piping must not be used in the presence of acetylene. Copper and acetylene will form copper acetylide. This compound is unstable and explodes at the slightest shock. Acetylene generator. An acetylene generator brings the proper amounts of water and calcium carbide together to safely generate the acetylene. There are low pressure and medium pressure generators. Safety. Acetylene is unsafe to use above 15 psi. Sources of ignition must not be permitted in acetylene storage areas. Acetylene can form explosive compounds with copper, silver, and mercury. Acetylene must be kept away from these metals and their salts, compounds, and alloys. Safety. Keep cylinders away from overhead welding or cutting. Keep flames away from the cylinder and hoses. Acetylene may displace air in a poorly ventilated area. Any atmosphere that does not contain at least 18% oxygen may cause dizziness or death. Leave the handwheel, wrench, or key on the cylinder valve stem for emergency shutoff. Pressure regulator principles. A pressure regulator is a mechanism installed between the cylinder and the torch lines to reduce and stabilize gas pressure. Most regulators have 2 gauges. The high pressure gauge shows the cylinder pressure, and the low pressure gauge shows the working pressure. Pressure regulator principles. 2 varieties of regulators are available: single-stage regulators and 2-stage regulators. 2-stage regulators provide more accurate pressure control and readings. Nozzle-Type pressure regulators. Regulators come in various gas flow capacities and nozzle orifice sizes. Safety. The flow of gas from the cylinder is stopped completely when the adjusting screw on the regulator is turned all the way out, or until no tension is felt. Stem-type pressure regulators. A stem-type regulator employs a poppet valve and seat. As pressure builds, the diaphragm moves up, closing the valve. Stem-type regulators are used where a high rate of flow is required. Two-stage pressure regulators. A two-stage pressure regulator may be considered to be two regulators in one. In the first stage, high pressure is reduced to an intermediate pressure. The second stage regulates the working pressure and gas flow to the torch. A two-stage regulator may use either a nozzle-type or a stem-type valve. Master service regulator. Large master regulators control the flow of gases from the manifold to the welding station line. These regulators must be capable of controlling large volumes of gases and always have two gauges. A high pressure gauge indicates the manifold pressure, and a low pressure gauge indicates working pressure. Line or station regulators. Line or station regulators are used in connection with manifold systems. They should be handled in the same manner as other regulators. They are usually equipped with only one gauge. Safety. Fuel gas and oxygen regulators and gauges must not be interchanged because a fire or explosion may result. Pressure gauges. A high pressure gauge registers the cylinder pressure when the cylinder valve is opened. A low pressure gauge registers the pressure of the gas flowing to the torch. The basic operation of a pressure gauge depends on a burden tube. As the pressure increases, it operates the gear and the pointer mechanisms. Pressure gauges. Heavy glass or plastic that covers the dial face is held in the body by a clamp ring called a bezel. There are sometimes two scales on a pressure gauge dial. One reads the pressure in pounds per square inch, the other reads in kilopascals. Pressure gauges. This diagram shows the parts of a pressure gauge and a cross-section of the pressure gauge. Safety. In case it hasn't been mentioned, it is dangerous to use acetylene at pressures above 15 psi. Safety is not a joke, and the repetition of this information should help you realize how important it is to keep acetylene pressure below 15 psi. Welding hoses. Hoses are built in several layers for strength. The hose is specified according to its inside diameter. Double hoses are most common. Safety. Hoses should never be interchanged, carrying first one gas and then another gas. If oxygen were to pass down a used acetylene hose, a combustible mixture would form. Welding hoses. Special precautions are used when attaching the hose to the regulators. The nut used to connect the nipple on the oxygen hose to the torch or regulator has right-hand threads and may be marked OXY. The regulator and hose fittings used for acetylene usually have left-hand threads and may be marked ACE. Never force fittings together. Safety. Hoses must be handled carefully to prevent accidents. They must not come in contact with any flame or hot metal. They should not be kinked sharply. Hoses should be protected from molten metal, falling objects, vehicles, and foot traffic. Oxyacetylene torch types. A welding torch and a cutting torch are each designed for a specific purpose. There are two types of welding and cutting torches: positive pressure type and injector-type. Positive pressure welding torches. The torch consists of 4 main parts: the body, hand torch valves, a mixing chamber, and a tip. Positive pressure welding torches. In a positive pressure torch, oxygen and fuel gas are mixed in the torch and burned at the end of the torch tip. Hand valves can be used to throttle the gases being fed to the torch. The mixing chamber is usually located inside the torch body. The torch orifice must be an accurate size for the material it is used on to achieve good results. Injector-type welding torches. An injector torch can operate using very low acetylene pressure. The pressure remains practically constant regardless of the size tip or thickness of metal being welded. The torch is able to draw out the last remnants of acetylene from a cylinder. Air-Acetylene Torches. An air-acetylene torch is often used where a light portable flame with a medium temperature is required. The torch receives its acetylene from a cylinder through a regulator and hose. Cylinders for small portable air-acetylene torches come in various capacities. Safety. The same safety precautions observed when handling an oxyacetylene torch should be used when working with an air-acetylene torch. Welding tips. After the gases are mixed, they are fed through the tube to the welding tip where combustion takes place. Always use tips made for that particular torch. Welding Tip Cleaners. Welding tips are sometimes subject to considerable abuse. The orifice must be kept smooth and clean. Welding tip cleaners have a series of broaching wires. A broach is a tool used to shape a hole. A drill bit of the correct size can be used to clean tip orifices. Welding goggles and protective clothing. Welders must wear suitable goggles or a welding helmet with the proper filter lens. The filter lenses are tinted either green or brown and are made in a variety of shade intensities. Filter lens shade for Oxyfuel welding ranges from a number 4 to 8, depending on material thickness being welded. A clear cover lens is used to protect the filter lens from metal spatter. Safety. Always wear safety glasses under your helmet or face shield. Welding goggles and protective clothing. Welders must always wear protective clothing. Hands should be protected with leather gloves. Gauntlet-type gloves are preferred. Jackets should be made of leather or a fabric treated to resist burning. Jeans should have no cuffs and should be made of fabric resistant to burning. Shoes must be leather, and safety-toed is suggested. Safety. A handheld flame should never be used to light a welding torch. Do not carry matches or combustible materials while welding. If a spark enters a pocket in clothing, a serious burn may result. Butane lighters can explode and should not be in the welding shop. Torch lighters and economizers. A flint and steel spark lighter is the most popular type of torch lighter. Pistol grip spark lighters are also available. A combination economizer and lighter has a mechanism through which the oxygen and acetylene are fed before going to the torch. Oxyfuel gas welding supplies. Many supplies are needed or convenient to have to perform oxyfuel gas welding. Welding gases, welding rod, fluxes, firebrick, carbon paste and forms, ventilation, and material to be welded. Safety. Keep oil, grease, and other petroleum products away from the welding area. They are highly combustible in the presence of oxygen and could spontaneously combust. Other fuel gases. Acetylene is the most commonly used fuel gas for welding. Other gases used include hydrogen, LP, liquefied petroleum, propane, and butane, natural gas, and polypropylene-based fuel gas. Other fuel gases. The oxyhydrogen flame is very clean and is recommended for welding aluminum and magnesium. Liquefied petroleum, or LP, is sold under a variety of names and can have a variety of chemical compositions. Natural gas is also an excellent fuel gas for certain uses. Safety. Hydrogen has no odor. When hydrogen is combined with air or oxygen in certain proportions, a powerful explosive mixture forms. Hydrogen connections should be regularly checked for leaks using a soap and water solution. Check valves and flashback arrestors. Check valves are used to prevent the reverse flow of gases through the torch, hoses, or regulators. A check valve allows a gas to flow in only one direction. Check valves and flashback arrestors. Flashback arrestors are designed to eliminate the possibility of an explosion in the regulator or cylinder. Flashback arrestors contain check valves and a stainless steel filter. Welding rods for oxyfuel welding. A welding rod is a form of filler metal used for welding or brazing. Some common welding rods include mild steel, cast iron, stainless steel, braze welding alloys, and aluminum. Welding rods for oxyfuel welding. The American Welding Society issues specifications for all types of welding rods and electrodes. RG45 is the most common rod used. Welding fluxes. Flux is a material used to prevent, dissolve, or facilitate removal of oxides and other substances. Fluxes are required when certain metals are heated to join them with solder, silver alloys, or copper alloys. The composition of a flux is determined by the specific application for which it is made. Firebricks. Firebricks are heat-resistant bricks or stones. They are used to form welding tabletops, build forms around articles, aid in preheating and stress relieving, and protect combustible materials. Firebricks are made of refractory materials. Carbon paste and blocks. Carbon in the form of paste, blocks, and rods is commonly used in welding operations. Typical uses include supporting workpieces to be joined, building dams to contain molten metal, protecting drilled or threaded holes, and as a protective cover over metal that is adjacent to a weld. Safety. Apply sealing compounds only on the male threads to lessen the danger of the compound entering the pipe. Avoid using sealing compounds that have a lead content. Sealing compounds with an oil content should never be used on oxygen lines. Only use firebricks for welding and cutting. Bricks used for building materials can explode when heated. Concrete can also explode. Clamps and clamping fixtures. The success of many welding operations depends on how well the metals are held in place. Many varieties of clamps and devices have been developed for this purpose. Specially designed pliers with clamping jaws for holding and aligning parts are available. Clamps and clamping fixtures. Very complex shapes can be clamped for welding with chain clamp pliers. C-clamp pliers can also be used to hold parts firmly in alignment. The illustration shows a C-clamp vice grip, one of the most common used tools for holding parts together to be welded.